Okay. So let's talk about the edge. So this is a kind of a fair question. What percentage of your workloads require ultra low latency to devices and end users? Anybody know the answer to that? Anyone want to speculate on that? No? Okay. Yeah. I don't know how many people need ultra low latency. You're either in the business that requires ultra low latency, but I don't. Most people don't spawn an application that suddenly needs ultra low. If you're in fintech, you probably need ultra low latency. If you're doing like leaderboards and gaming where the social expectations are low, sure, right? I would say anything involving military telemetry, when you type, that's going to be pretty low latency, right? Any threat responses, that's going to be low latency. Christian, I don't know what ICS-OT is. Could you explain that?
Industrial control systems, closing off valves for nuclear power plants, that type of stuff.
Really? I don't know. I feel like you could take a couple hours or a couple minutes to drop those control rods into the reactor. I don't know that.
Well, oddly enough, nuclear reactors are built to go ahead and take a little while, but I prefer ultra low latency for those types of things.
Indeed. That way you can get the things under control when there's snowflakes instead of avalanches, right?
Exactly. Pharma, like temperature changes, adding microgram stuff. So we have to be able to change flow gates at micro transaction levels.
I have to agree. Any form of cooking, whether it's chemical cooking or anything like that, like all I think requires, right, low latency. Okay. Now, I don't know how this is going to apply here because what you're talking about is way at the edge, but still, right? Still applicable. When we're talking Honeywell, we dealt with a lot of that stuff.
Exactly. That's all Honeywell is. And yeah, if it's me, we're probably going to talk about an edge case anyways.
Yeah, fair enough. Well, good thing we're on edge services, but I don't think those are the kind of edge cases you're talking about. So bottom line is that this whole chapter, this whole module is really just about how do we serve things globally, mainly from web services, because that's what Amazon is used to delivering. So whether it's a content delivery network or accessing files or reducing latency, that's the focus of this chapter. There are some distributed denial of services and WAF kind of components into this as well. So we will talk about shield standards, WAF, that kind of thing. Oh, and we're going to talk about Outposts. I forgot about Outposts. Outposts is us running Amazon's hardware basically and their services inside of our data center. So, here you've got DNS on the left-hand side, and then we're going to talk about Global Accelerator, which is basically a global kind of load balancer, if you will, global redirector, traffic director, and then CloudFront, which obviously is the content delivery caching that we've been referring to. And then Shield Standard, which comes with every account, is basically Amazon security team doing distributed denial of service protection. And then we've got WAF, which is the web application firewall. Those firewalls have been around for a while. What they basically do is they filter malicious or wanted traffic. They filter for that traffic and either allow it or deny it based on managed rules. Sorry, rules that you put in, not managed rules. So we're going to talk about all these like different pieces. The questions that we're focused on is basically, how do I improve the performance of web-based applications? How do I reduce latency and security of your data center? What if you need a static IP address with a regional failover? So basically you need to do global load balancing. How can I run workloads in my own data center using AWS services? And then basically how you can protect public facing applications. I mean, does anyone think the internet is a safe place? I don't. If you take a fun experiment that we usually do at the first of the year, so a buddy of mine, Chris Kelly, and I used to annually stick Windows boxes and Linux boxes with like firewalls turned on and stuff on the internet unprotected, just to see how long it would take for them to get hacked. The Linux boxes actually typically did longer, and then we added Mac OS about 2 or 3 years ago. But typically the Macs and the Windows boxes would all be hacked within about 30 to 40 seconds, right? And then the Linux box would last longer. But if you left it on for 15 minutes, that thing was gone, right? It was, if you stick a box directly out on the internet, it's shocking how quickly it gets hacked, no matter what it's got on it. And now I say no matter what it's got on it. We had a bunch of limited use cases, but I'm sure if you hardened it to DoD specification, blah, 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 I'm sure it would protect itself better. But man, out of the box, like vanilla installations, even with a little bit of hardening, no good. So edge fundamentals. What are we talking about when the edge? Because they used to talk about how there was cloud computing and there's core cloud computing, then there's edge. And then they start joking about how there's like fog computing. There's this like space in between the extreme edge and in between the cloud, and it's like fog computing. I remember people are trying to like get that to stick, and I was like, that's dumb. But hey, I'm not here as a pundit of the industry. I just thought it was silly, right? But defining the edge basically says, from AWS's perspective, says, look, you're either in a region, otherwise you're at the edge from their perspective. Meaning you're either in your own data center, right? Which is what Outpost represents here on the lower left. You're in a cellular 5G location, which is what Amazon offers, right? So just so you know, they also offer these wavelength zones, which are basically 5G, like centric towers. Like they basically are using these 5G providers would use these as their edge location. So if you're like a provider of like cellular anything, you would use wavelength as a way of kind of pushing your applications closer to these kind of edge portals, if you will, for cellular. And then local zones we talked about, which is basically just an extension of availability zones, but outside of a region. So near a major metropolitan area, Boston, Los Angeles, Philadelphia, Kansas, pick your poison there. And then really the global locations is the edge location. So this is where the servers are scattered all over wherever there's a major ISP, not necessarily just near a major metropolitan center. And this is how they define the edge. So how do I run things globally using this edge infrastructure? How do I run things in local zones? How do I run things in outposts? And how do I run things at these wavelength locations? We're really actually only going to talk about edge locations and briefly about outposts. That's it. We're not going to talk about local zones because most of the services like EC2 and ECS and EKS will run already in these local zones. And we're not going to talk about 5G providers because that's really an edge case. We don't need to discuss that. I'll save it if you work for Verizon or Sprint or somebody. Now these edge locations, now notice they just kind of like didn't really like list where these are all the regions. I'm not sure what this map is supposed to represent, but we need to throw a whole lot more on here. There's like 300 edge locations, and these are either a couple servers or a whole rack of servers that's inside, usually an ISP's data center. It can be an Amazon-owned data center. And the idea is this, is that these like scattered 300 stacks of servers all over the world, their job is to intercept communications that are meant to go back a long distance and provide access to Amazon's high-speed backbone. They're also meant to provide caching. So that's what these points of presence or these edge locations are supposed to provide. This map doesn't really do that justice, but there's like 300 of them and they're scattered all over the world. So way more than the, soon to be 34 regional zones that are available. I also do want to mention though, is that inside each of these regional locations, there is actually a caching location. And I mention that because CloudFront actually does some interesting things where instead of having to go all the way back to the origin, you can actually go back to a regional data center, which might have a longer lived cache inside of it. I can't remember what that's called inside of CloudFront, but we'll probably see it here in a second. So CloudFront is like Fastly, Cloudflare, Akamai, others, right? It's a content delivery network. Now, again, even this edge location map is horrible. It's missing. There's a couple in Brazil. There's a couple in South America. There's 2 more in Africa. Anyway, it's close, but it's not necessarily up to date. In 2021, there's a whole lot more edge locations. It's not 230. It's way more. I actually had a person in my class a couple of weeks ago who worked for Amazon because I was teaching it. I know this sounds weird, but I was teaching to Amazon. And interesting, Amazon doesn't have their own trainers teach. They have me teach. They were just busy. There's no slide on that. So one of the guys in there was actually an edge location installer, and he talked about, the pieces that he could talk about because they're all under NDA, of course. And it was really interesting. like they're up to like 300 plus locations now, well above the advertised and documented location set. So they have servers everywhere now. The idea here is, how do we get content from a single source spread out all over the world? So if you have a website which is mainly comprised of static HTML, you could actually push that static website all over the world. And even the dynamic content can actually be, to a certain degree, shoved over these servers because they're all connected through Amazon's high-speed backbone. So, without edge caching, nobody's in the middle of these connections, and you're going all the way back to the origin, right? So request response, right? I want this. Okay, here it is. I want this. Okay, here it is. Now with edge caching, what changes is that Route 53 with a CloudFront distribution intercepts the fact that a user in Bolivia has asked to talk to something in the United States. And what it's going to do is it's going to redirect it to the closest like South American server. That server high-speed backbone is then going to go back to North America and do its thing. So we're talking about decreased latency, increased security. And what you do is you create a distribution, which means this is the source, and this is how I want you to cache it. And there's a lot to the question of this is how I want you to cache it. You can force TLS. You can force everything to expire in 5 seconds. You could do it in an hour. You basically define all the behaviors for how the sources work, and you could have multiple origins. So you could have a primary origin and then a failover origin, which means if this doesn't work, go here. CloudFront, by the way, I end up using this a lot for setting up status pages. When you go to a website, it's not available, and you fall back to an S3 bucket that has, a static web page that says, hey, we're experiencing some issues. May the force be with you, or whatever funny message you want to send. I usually appreciate those. So oddly enough, I end up using CloudFront on stuff, even if it's not going to be cached. You know what I mean? So it's kind of fun. CloudFront is a content delivery network, just like any other that you use. One difference is that when you pull data out of AWS using CloudFront, they're not going to charge you for it. If you use Akamai, they're going to charge you for it. Use Cloudflare, Cloudly, etc. Short but funny story. A guy over Christmas break, God, 6 years ago, actually, came to me and said, hey man, I know we're not making any changes, but I want to shrink this JPEG down from 100K to 60K kilobytes, just so we're clear. He wanted to drop this file by 40K. And that's all he wanted to do, is he just wanted to change this core file that was embedded in like our video distributions. He just wanted to change the file. I was like, that's fine. I don't care. As long as you don't change the name, and he can increment the version number, because that doesn't really do anything. But he incremented the version number because we usually didn't accept changes over the holidays. The next month, our bill with Akamai and AWS was down by a significant amount of dollars because he dropped this file by 40K. Turns out, by the way, that file was downloaded and pulled out of AWS 8 billion times a month. And then it was cached in Akamai. So not only did we reduce our Akamai charges because this file, which was downloaded 8 billion times a month, was it less, but our egress charges from AWS were less as well, because he shaved 40K off a file that was downloaded 8 billion times a month, right? Now you might ask yourself, well, Michael, why was it downloaded 8 billion times a month? Why wasn't it cached somewhere? Sad face. All right. So bottom line is that this is a content delivery network. It will integrate with security tools. Doesn't matter if it's static or dynamic content. It will help. It helps more with static content. So it will, by the way, support real-time bi-directional communication with like WebSockets. So if you're not using REST, you could use WebSockets. This is going to allow you to open a persistent connection and send data real-time without the overhead of repealing the open connection. So this is WebSockets is really good if you're using chat, collaboration, fintech, financial trading, gaming, be another one. So yeah, so just know. Just so you're aware, CloudFront will usually respond if it has a fresh cached copy that meets your requirements. If it doesn't, it's going to go back to the origin and say, hey, I need to get a copy. So step one is that the customer talks to CloudFront. CloudFront then talks to Origin. Origin talks then back to CloudFront. And then the CloudFront Edge server will then talk back to the customer. You can modify and transform any stage of these 4 stages. So like if you're like, hey, when the Origin sends me back this file, I want to do some kind of modification, or I want to change, set a policy for what happens there, you can do that. But just know that if the edge location already has a fresh copy of the content that the user is looking for, it's not going to do steps 2 and 3. It's just going to feed out its cache. If you have a video file that hasn't changed in 24 hours and the 50th person comes and asks for it, there's probably already a copy there, right? So just be aware that you don't have to necessarily manage the expiration of cache. You just have to set times to live. Like, what is the maximum amount of time you want this file to be fed out for before it goes back to Origin to find it? And just to say this, if you're worried about releasing new versions of your product, just to be very explicit about this, you need to put version names in the names of your objects. Not only will that help with troubleshooting, like when you like the browsers, like caching stuff, but then you don't have to worry about busting cache. If you go from JPEG version 3 to JPEG version 4, and your version 4 is your latest, then you don't have to worry about busting the CloudFront cache in order to get it to update. You're versioning your assets and just make everything the same version number, even if you haven't changed it. Make it all version 4, make it all version 5, right? If the only thing you've changed is 5 JPEGs, just move everything forward ahead, right? Don't worry. Your repo will tell you what's actually changed, but just version everything. This avoids the caching problem as far as like busting cache. Busting cache, by the way, is a term that just means you're invalidating the time to live on that object. So it will force CloudFront to actually go back to the origin and pull it back. Now, you can also force CloudFront when you make the request with the browser to force it to go back and look for an updated copy just by putting the cache control header to 0. Just say, hey, go back and get another copy. You do have to enable that inside the CloudFront settings. You can configure CloudFront. So first you find your origin, then you set up your distribution, which is going to basically point towards the origin. You set up all your behaviors and policies. You're going to get a URL for CloudFront, which is actually a meta DNS pointer, meaning it's a DNS pointer that's going to return the closest edge location to the user. And then everything just starts working. You can define, by the way, whether you want it to globally cache or only cache in the United States or only cache in Europe. You get to set up all the caching options you want. Okay. Now, what can you use as an origin? You can use something outside of AWS. You can use an app, a load balancer, an S3 bucket. As long as it's a web-based URL, you can make it happen. Behaviors could be everything from, hey, if it's star.jpg, go here. If it's star.html, don't cache it. If it's, an API call, don't cache it. You can actually set all kinds of behavior. You can create pre-signed URLs. You can create pre-signed cookies. You could terminate TLS here. For example, you can put this in front of an S3 bucket. S3, by the way, can't usually do TLS because it's just a static web server. It doesn't do TLS by default. But you could put CloudFront in front of it and make it do TLS there. So you can put SSL in front of it. God, there's lots of CloudFront has a bunch of options. So, excuse me. Here's an example. Okay, this is a good one. So here, by the way, with CloudFront, if they're grabbing an HTML file, it goes over to the load balancer, but notice the time to live is 0. Which means it's not going to cache any object it gets from that load balancer up top. In the bottom, notice the time to live is 3,600 seconds. So when it downloads a JPEG, it's going to keep that JPEG in cache on the CloudFront server for an hour before it goes and checks and see if there's another one. So, you can make it so that dynamic content still benefits from CloudFront, but it's not going to try and cache that content. It's going to force you to go back and grab it from the server every time. But CloudFront will run it over its high-speed backbone. So you'll still get benefit from content like that, but you won't be able to cache it. Hello, Alexa. You can, by the way, do things like geo restriction. Like you can set up geo restriction here, so you can like restrict things by location. Say, look, you can restrict access at the country level. If you want something finer than the country level, like you want zip code or city state or whatever, you're gonna have to use a third-party service for that. I believe that CloudFront does actually support third-party geolocation services. That integration, I am not 100% clear on. I don't think I've ever used a third-party service because I mainly use DNS for geolocation, but CloudFront can do geo restriction as well. All right, so that's CloudFront content delivery, right? Know that you got origins. You can set a primary and a secondary failover sites as far as origins. You could have multiple distributions in there. Yeah, and it does integrate with all your security tools. Okay, so that, if we go back to the very first thing that we were looking at as far as like our cases here, that's the bottom of these two where it's like Global Accelerator and CloudFront. So now what we're going to do is we're going to talk about Global Accelerator. So Global Accelerator is interesting because it's kind of like a global traffic director, global load balancer, but it doesn't really manage connections. So it's more like a traffic director. So, so think about this. If you're coming from your local ISP, you might go over a number of hops to reach the application. These public networks, by the way, are under contention. This can introduce availability and performance risks. How do you manage this for critical workloads that need a higher level of availability and a higher level of performance? And you want to run something multi-region. Like, how do we get to global load balancing? Like F5 and those like people, they have global load balancers. How do we do this inside of AWS without using a third-party app? Now, I just want to forewarn you, just because I have directed all of your traffic to multiple regions, remember that if there are data stores, like databases involved, especially if you're using one database for your entire application, replicating data is the biggest challenge, still solvable, but still the biggest challenge whenever you decide to go multi-region. How are you going to maintain data consistency between those two sites? It's a different problem, by the way, with data consistency. If you're like, hey, I want you to direct people who are in North America over here, that's a database, and it's Europe, and that's a database, and it's Asia Pacific, and that's a database. Those databases don't necessarily need to sync with each other. But if you're trying to maintain one global database, right, that can be somewhat of a challenge. So just remember, this solves the front end, but your back end data synchronization issues might still persist. So just keep that in mind. So with Global Accelerator, what you can do is, instead of having this jagged kind of like unusual and unexpected and unpredictable level of availability and performance, you can put this device in here. This is going to give you a static anycast IP address. And then what happens is that when you hit this IP address, it's going to redirect you to the closest data center. Notice that there's a bunch of like anycast endpoints here. What this means is that this IP address actually exists in multiple locations. And when someone hits it, they go to the closest instance of that IP address, and it redirects them to the closest data center. If one of these data centers goes down, it's going to redirect you over to the one that's available, assuming you have it set up for that, right? So that's the way this works. Multiple existences of the same IP address, users are routed to the closest existing IP address that's closest to them. And then that point forward, it's going to redirect them to an available data center, the closest one preferred. You can also, by the way, increase or decrease the percentage of traffic to a particular endpoint. You can configure weights for the endpoints. It does support TCP and UDP. So you can like tune how this like distributes traffic. Like I said, it's like a traffic director, right? Now, Global Accelerator operates a little differently than CloudFront because CloudFront is layer 7. This is web-based protocols. Global Accelerator is level 4. Notice that, CloudFront's going to be a content caching mechanism. Global Accelerator is a traffic director. That's what it is. One's DNS based, which is not great for like quick failover, and the other one's based on anycast IP addresses. So, yeah, the rest of this, obviously makes sense. You can read it. So just remember, CloudFront's content delivery network, Global Accelerator is a global traffic director. So. Okay. Questions about any of that traffic redirection or anything else there? All right, let's talk about distributed denial of service attacks. Why? Why not? Okay. So you may remember the OSI model. I know some of you are probably having PTSD right now. Just know that I care for you, and I'm sorry that you're having to see this, but it is a great way to talk about network layers, right? So here, just to say this, is that, we've got the physical media layer, and then we've got the host layer, right? As far as like how we divide this up. The main focus for infrastructure layer attacks is going to be at that network transport level. So layer 3 and layer 4. And then, there's application layer and presentation layer attacks. They're going to be at higher levels. Now, depending on how the attack is executed, right? So whether it's like a send flood or a reflection attack using UDP, the idea here is that infrastructure layer attacks are trying to overload the network stack of the service in question. Application layer attacks may also try to overload, but they also might try to send malformed responses or control responses like requests to the layer 7, like little Bobby drop tables from XKCD, trying to get you to drop your production tables because they want to disrupt your service in some form or fashion. How many of you remember little Bobby drop tables from XKCD? You remember that? I'm old. Used to be a cartoon, and it joked about how this kid hacked into his school and caused it to drop all the SQL backends. And they said, yeah, we call them little Bobby drop tables. So, yeah. Anyway, so by default, just by opening an AWS account, AWS's security team is going to protect you from denial of service attacks. Can you imagine how many hackers are out there just saying, man, if we could just get past AWS's firewalls and get some of that sweet, sweet data that's out there, we would, have insider trading inside or whatever. Now that still happens, but I don't think it's necessarily because they've hacked AWS's infrastructure per se, at least not yet. But Shield Standard is included. There's also Shield Advanced. Now, in order to deal with layer 7 attacks, you're going to need to use something like a web application firewall, which is going to filter out these malicious responses. So WAF is mainly what they use when they want you to block these layer 7 attacks. So note that the way WAF works is that you basically set access control lists. You've got rules inside there. The rules can be nested, by the way, and the rules can either come from Amazon, you can buy them from a third party, or you can make your own rules. By the way, when you buy them from a third party, they will be dynamically updated with known bad actors. So make sure you trust the known third party. Don't just pick some random person, like do a company that you have a relationship with. Notice that the WAF can sit in front of an ALB, an API gateway. It can sit in front of AppSync, which is basically just GraphQL, and then CloudFront. So just know, the WAF can sit in front of a bunch of things. The WAF does sit outside of the core network. So just so you know, it will sit in front of all these edge locations. The access control components, the ACL components, does consist of things where it's like you have a web access control list. This is used to protect your resource. So when you create it, you define this protection strategy by adding rules. Rules are going to define the criteria for inspecting the web requests that come in. It's going to specify how to handle those requests. Am I going to allow traffic if it matches, or am I going to deny traffic? Each of the rules inside an ACL is put into a rule group, and each rule contains a statement that defines a very specific inspection criteria and what action to take if the web request meets this criteria. In other words, if it says drop anything, you might have it say, no, I want to deny that traffic if drop is in the string, right? It might be if it only comes from any IP address. It might be that, hey, look, that kid in Colorado, I don't know why I'm picking on Colorado. That kid in Colorado keeps trying to hack my servers. He's just blocked, you know? And so, and you can do pattern matching here. So if you want to bring in the voodoo magic of regular expressions because you want to do something really powerful, but maybe complicate your life, just know that you can also bring in regex sets as well, right? It's going to log out. It's going to like make metrics. Once you get to CloudWatch, by the way, you can also trigger a CloudWatch event. You can also trigger a response with CloudWatch events if you want it to lock down something based on someone trying to repeatedly attack a system or whatnot. Now, a web ACL consists of a set of rules and rule groups, right? And you can put multiple ACLs inside of a WAF. Now, when these ACL rules themselves come in a couple of different forms, depending on what you're trying to do. You're either trying to prevent an attack, which you may also be traffic filtering as a part of that. You might be matching a pattern. You might have logical operators like, I want you to check if the user is trying to do this and they're from this location and they're coming in on this port, block them, right? So you can do and statements, you can do or statements, or not. Anybody who's not in Colorado, then I know I'm picking on Colorado. It's like, anyways, not in Colorado doesn't have to follow this rule, right? So this is very powerful. It can get super complicated. My recommendation is to experiment with it first, maybe even buy a subscription to somebody else's rules. Don't put them in production, just see how they function first and then write your own rules. So, by the way, there's lots of rule examples out there if you want to dig them up. Now, if I talked about WAF and I didn't talk about the firewall manager, well, shame on me. So just know is that the firewall manager will allow you to simplify security group and WAF administration. And this includes, by the way, the network firewall, which we don't usually talk about until the pro class. But the network firewall is another firewall service that will allow you to do deep packet inspection and other things to your traffic. So just be aware that the network firewall exists. It's not usually a pro level discussion. It does not show up on the exam at all. But the firewall manager is going to help you simplify management of rules across all accounts and all applications, like this from a security group and a WAF perspective and the network firewall. It will discover new accounts if they're added automatically and remediate any kind of non-compliant events that happen. It will deploy WAF rules from the marketplace or from your own rule set. And you can actually rapidly respond by pushing a rule. Like if all of a sudden, like log4j, for example, if you're like, hey, I need to block, a particular like JNDI port, it's like, push it out, right? JNDI port. Whatever. If you need to block a particular port that maybe make you vulnerable, you can do that with Firewall Manager. Let's see. Is there anything in the notes that I didn't talk about? Oh, yeah. So one thing that's worth mentioning is that you can't use Firewall Manager unless you're using organizations, right? Because otherwise it's going to assume a role and push across organizations and da-da-da-da. You also have to use AWS config, and you have to make sure that someone is explicitly assigned in the organization as a firewall manager administrator. So there's like 3 little things you're going to do. So you need organizations for this to work, and you need config for it to work. Firewall manager is really good if you have a large set of rules, like a baseline set of rules that you need to apply across a large number of objects. If you need central visibility, right? And then, of course, if you're always vending new accounts and vending new applications, This is a great option. Here's the DDoS resilient. Notice it didn't say DDoS denied. DDoS perfect architecture. Didn't say that, right? It basically just says, hey, let's do this. Is that why don't we put Shield's already in front? And by the way, you can buy Shield Advanced, which usually is a pro level conversation. But if you want to get cost remediation and you want to get the access to a 24/7 team to talk to at AWS, you can buy Shield Advanced. I think it's a year commitment, and I can't remember what the cost is. I want to say it's like 18 grand or something for the year. Otherwise, you're gonna push rules from the firewall manager into your WAF, and as things either come in through the API gateway or into CloudFront, they're gonna get protected there. I don't know why there's an arrow straight to API gateway. Why wouldn't we put the WAF in front of it? I don't know. Anyway, so then CloudFront sits in front of the load balancer, and then load balancer obviously is in front of the EC2 group. Now they're missing the statement around the NACLs and the security groups here. There could also be a network firewall here. You can really beef this up from a security standpoint if you want to. Turn on flow logs, turn on CloudTrail, set up a guard duty. Like there's a bunch of things you could do that would make this at least detective, if not preventative. All right, so that's DDoS protection, which mainly consists of Shield, WAF, and the firewall manager. Questions? Cool. All right, let's talk about this. This one's going to be short and sweet. Why? There's not much to talk about here. So if you want to run AWS hardware in your data center and have it managed by AWS, you can also, by the way, do OTF, so it can be over the air if you want to. OTF. So does that mean OTA? Anyway, so if you decide, what will happen is that when you request this, Amazon's going to contact you. You're going to ask you a bunch of questions. You're going to have to verify that your site meets the requirements for Outpost. You must have an enterprise support plan. They will not even let you use Outpost if you do not have an enterprise support plan. Good thing Booz has like a Uber support plan. Then they're going to schedule a date and time with you. You're going to get a checklist that has to be fulfilled before they'll come out. The team's going to roll the rack to the identified location. And then what's going to happen is that, and then they're going to ask your electrician to power the rack. Then they're going to establish network connectivity over the uplink that is provided. They're going to configure the rack's capacity, and the installation is complete when you confirm that you can see the EC2 and EBS capacity of your Outpost in AWS in the account. So services that you can run: EC2, ECS, EKS, EMR, RDS, VPCs, and EBS and S3. Notice that DynamoDB is not here, although that might have changed, but I don't think it has. DynamoDB is not here. So this is by far not all services. Lambda is not here, right? So ECS, EKS, and EC2 are your compute options. EMR, by the way, uses EC2. RDS obviously uses EC2. ECS and EKS also uses EC2. So there's no serverless launch types here either. Okay.
So they configure these services in my data center?
No, Vinod, they roll out a set of hardware that allows you to run these services in your data center.
Oh, okay.
So it's ready to go out of the box.
Mm-hmm.
They don't configure anything other than network connectivity.
Gotcha. So if I don't want to, what would be the use cases? Like maybe the performance, the latency, or
yes,
what you
yes.
call store data sensitivity?
Yes, keep going. You've come up with great use cases. I don't have to offer any at this point. Yeah, that's exactly right. If you have either a performance or a security requirement to have it in your data center, those are great ways to think about it. Christian, were you going to add something else to that?
I said the fact that you now have these managed services in low latency.
Yeah. Yeah. I mean, if you control the network, how low could that go, right? I know at least one missing. there's a couple missing off this. At mesh, I think, is another one. Anyway, I'm sure there's an updated list, but these are the core, the most important ones.
Maybe a load balancer. We need load balancers.
I don't think ELBs are part of this, but honestly, I've never run an outpost. I've never even had a customer consider this.
No, I'm not
Right.
saying it's there. I'm just saying we probably need load balancers, don't you think, for some of these?
Well, and I think what they do is they'll support your load balancers, but I don't think that
Oh,
they,
okay.
I don't think that I don't think they run ELBs here. So. Yeah. I almost got Honeywell to buy one of these, but we got Azure Stack instead. We got the Azure version instead of that. So, which is totally fine. Okay. What are the potential benefits of implementing a CloudFront distribution? And please do not say 2 global static IP addresses. You know what that is. It's not CloudFront. Okay. So it seems like everyone can agree on D. Reduce latency for access to application content, right? Kristen, you added A. Sean, I see that you added C. Unfortunately, it doesn't provide automatic redundancy, right? So just to be clear, it's not redundancy, right? The reason is that once the cache expires, you're going to lose access to that. So while it might buy you a measure of delay, it's not redundancy. It's not like real redundancy. So it's really A and D are the options here, right? You get a little bit more application security because you can turn on TLS, you can do geofencing, you can turn on filtering, and then reduce latency for access to application content, because that's what it's there for. That's really what CloudFront does, is it reduces latency to users. 2 global static IP addresses is global accelerator, so no. And then automatic redundancy, it's just the word automatic that's the problem, right? And honestly, redundancy is also an issue. It really doesn't provide redundancy. It just masks it for a minute. Which of the following services offer denial of service protection? Which will protect you against distributed denial of service attacks? Whew. Those were quick answers. Yeah, I mean, Outpost definitely not. Global Accelerators doesn't do anything for that other than redirection. Network load balancers don't either, other than, again, high availability. But Shield and WAF are the actual security services for this. So make this happen. All right, my own question. What's the name of the service, by the way, that will allow you to distribute rules to your WAF, to your security groups, and to your network firewalls, as long as you're using an organization? What's the name of that service? Good, Firewall Manager. What's the name of the service that you can pay for an upgrade for if you want more distributed denial of service attack protection by getting into a relationship with AWS's security team? Good. Oh, okay. Are we making up names now? Come on. Shield Advanced. Shield Advanced. Come on. And this time it's not Elastic Shield Plus, which would actually be a good name for it, but Shield Advanced, right? So not just Shields, because Shield comes with every account, but Shield Advanced. In order to use Outposts, you need this with AWS. What is this? It's a certain type of plan. Vinod, good. Enterprise support plan. You need that in order to actually do this with AWS, right? You can't do Outposts otherwise, they won't let you. Deep freeze. Hey, deep freeze is a great name for deep archive. Good. All right, so last question. What is the name of the source that you create in a CloudFront distribution? What's the name of the source in a CloudFront distribution? It's also known as a good origin. That's what we're looking for. It's an origin. All right. Shall we go on to lab 6? This is going to be your last massive lab. Okay. So here's what's going to happen is that you're going to explore an existing CloudFront distribution. Hold on. Michael's going to check on something. 4 errored. Really? I don't like that. All right. Anyway, so it's restarting. So you're going to create a CloudFront distribution.
I have a quick question. You keep pre-warming. So later on, you said the labs will be valid for 2 months. So do we need to request somebody at WebEdge to warm it, or it's available anytime for us?
No. The only difference is that it's going to take about 5 to 15 minutes to provision. So
do
when
we need
you
to do
do
that
it,
every time?
when you do it, it's going to take 5 or 15 minutes to provision. But it's not going to take away from your timer.
No. What I'm asking is today when I was earlier in the day, I was trying to look at the lab for today, and it was not, letting me start. Looks like you need to do something to start for us to start.
Yes. So currently, you're right. So just to make sure I'm clear about this, not all the labs are activated. Like the Capstone lab is not activated, but by the time we get to the end of the day, all the labs will be active. Right? So the labs are activated as we get to them. But Sean, you won't run into that problem after we quit class because all the labs will be active.
Okay.
So there's like, is it on or is it off kind of state that I have to flip the switch on before you get access? If I had known you were running a lab, I could have turned it on ahead of time. So sorry. I don't usually turn the labs on until we get to them. I just realized there's a list afterwards. So instead of me trying to figure it out, maybe I'll just rattle it off. So CloudFront distribution, you're going to create an S3 bucket. You're going to configure the lab bucket for public access. That's going to be fun because that's going to have you doing a resource-based policy. So you're going to set the ACL. Then you're going to upload an object and test public access. Then add the bucket has an additional origin to the distribution. So you've already got a CloudFront distribution. Now we're adding like in a sense, another origin, an additional origin to the distribution. Think of it as a failover origin. Then you're going to secure the bucket with a CloudFront, which is called an OAI. Please remember that I said this, Origin Access Identity. An OAI allows you to make it so that your bucket will only allow connections from CloudFront. That's called an Origin Access Identity. You will be asked probably at least one question on that. Now, once you secure the bucket with an OAI, an Origin Access Identity, what's going to happen is you're going to test access to the file with S3, which should fail. You should fail the S3 in step, 7. And then you're going to test the access to the object using CloudFront, which would then work. So just so you know, the first time you access S3, it should work. When you get later on down in the lab and you access S3, it should fail because it should prevent you from getting access unless you're CloudFront. So if we go look at the lab itself, please make sure you've already hit Start Lab. Distribution, S3 bucket, configure the bucket for public access, upload and test an object, add the bucket as an additional origin to the CloudFront distribution, secure the bucket, test the direct access, which should fail. So task 7 should fail. And then task 8 is you're going to test the object using CloudFront, which should work. And then just so you know, task 9 is that you're going to set up cross-region replication, which is going to be fun. Okay. Now, as far as timing goes, technically, you should stop around 2:35. So that's about 40 minutes from now. So go ahead and hit the start button. Go ahead and get cracking on lab 6. And this is going to be the last kind of like simple lab that we have before we get to Capstone. Okay. Any questions at all? I'm here. Let me know. And otherwise, let's get to it.